Hey guys, so I wanted to make a quick video just about this brain teaser to get you guys thinking. It says, at what age does the rule not work? So the rule that we're specifically talking about refers to this rule here, which is about the half plus 7 rule. So the rule is y equals 1 half, right? 1 half or 0.5, however you want to write that. A representing the older person's age plus 7, right? And just to go back to what we're talking about here. So we're talking about the fact that a person's age, right? We have to determine how old the youngest person can be for us to figure out if it works, if that half plus 7 rule works. So when does the rule really start to make sense is what we're trying to see here. So apparently the rule here starts to make sense when someone is 14 years old. And let's figure out why. So we know that the input is the older person's age. So the A is the older person's age, in this case, 16. Let's see. So when my input is 16 and I, obviously evaluate it, so I have y equals 1 half or zero point 0.5, again, however you want to list that, parentheses 16, right? Plus 7. Let's see what we get. So half of 16, I'm multiplying here. Half of 16 is actually 8, right? So y equals 8 plus 7. 8 plus 7, which equals to 15, right? So my output for that one, right, was 15. So okay, that actually works. So this here works. That's why we have a check mark. It is possible. Now for 15, when my input is 15 and I follow the same rule, my output is 14 and a half. So 14 and a half is the youngest age the person can be when the older person is 15 years old. For 14, the output is 14. But now look what happens. When that input is now 13, right? And I'm just going to erase this part here. See if it works actually. This is my eraser. So now what winds up happening is that I am going to have 13 as my input, right? This is the older person's age. This is the older person's age now. So I'm going to do an example with 13 now. And I'll use a different color just so that we can differentiate there. So y equals 1 half, right? 1 half or 0.5 again. Parentheses 13, right? The older person's age, because the younger person's age is what our output would be. So we're trying to determine, okay, how young can a person be in order to date this person here? Let's see if it works. So when I input 13 plus 7, and we can use a calculator, guys. So you guys have that as a tool. You should always, when possible, use a calculator. Half of 12 is 6. So half of 13 is 6.5. Let's see if that works. So 6.5, right? If I add 6.5 and 6, that's 12.5. And then if I add that other half, that gives me 13. So this is where, well, 13 and a half actually. So now look what winds up happening. The youngest person that I can technically date is 13.5, and that doesn't really work because now this person is older than me if I was the older one. So that doesn't really work, which is why we have this x here. Let's try it again for 12. So let's see. Let's use our eraser. So when my input is 12, so 1 half again, parentheses 12, I'm technically, remember, the older person, plus 7, right? Half of 12, right? Half of 12 is 6. So that would be 6 plus 7. 6 plus 7 equals 13. So this is a 7. This is a very weird 7. Y equals 13, right? So you're telling me that me, as the older person, am going to date somebody that's younger than me, that's 13 years old. They're not younger than me. So this is when the rule stops working, and that's a way to evaluate it. Now, in method 2, it says solve the equation. So let's think about that real quick. It says for half plus 7 to make sense, the person must be at least as old as the youngest possible partner. The person must be at least as old, so the same age as the youngest possible partner, which is why here this is okay. 14 or 14 is okay. And the word here, keyword at least. Person's age must be the same or greater than the youngest age. So now we have an inequality, which is A is right. So the older person can date anyone who is the same age, right? Or older. That's why we have that little symbol down here. Or older plus 7. So we turn that into that inequality there. Now, when we try to fill in, right, to solve this, when we try to solve this, let's see what happens. We want to get A by itself. This is going to tell us basically what's the youngest possible age that this could work for. And the way that we solve it is obviously getting A by itself. So now we have 0.5A, right? We subtract 0.5, 0.5A. Same thing here, but this one would cancel out. So now we have 0.5A, right? Because we still have half the A. 0.5A is greater than or equal to 7. And now I'm going to divide that. So 0.5, let's see, 0.5. So if I was to divide 7 and 0.5, and obviously, like, I just want to show you guys what that would look like. Oh. 7 divided by 0.5, oops, not plus, 0.5 equals 14. So basically, what that means is that a person, when it starts working is when somebody is at least 14, and we can see that here on the table, because you can be the same age, but you can't be older than the quote unquote oldest person. So that's why it doesn't work. So we need to keep that in mind. These are two ways to kind of like figure that out. Let's continue on with the next part.